Right, hello Year 9. I'm going to go through some ideas relating back to the atom. So you should recognise this diagram from units that we've done in the past. So this is what the inside of an atom looks like. You've got the nucleus in the middle, which contains the protons and the neutrons, and then the electrons are whizzing around in the orbits outside. Okay. Now, something that you need to remember for this part of what we're thinking about is the mass of the different subatomic particles. Okay, so electrons are so tiny that basically they have virtually no mass at all. They're so small, and so we describe them as having 1/2000th of a mass. Okay, now protons and neutrons both have a relative mass of 1. Okay, it's not got a unit to it. It's just a comparative mass. Okay, so they are the two heavier of the subatomic particles, and they're both inside the nucleus. And the mass of those two particles is really important in terms of what we're going to look at today. So in your periodic table, you know that you've got all the squares set up like this or similar. You've got the name of the element, the symbol for the element, and then two numbers. Okay, so the small number at the bottom is the atomic number, or the proton number, which tells me the number of protons in an atom of each element. Okay, so for sodium as the example, sodium has got 11 protons in its nucleus. Now, because atoms don't have a charge, that also means that it contains 11 electrons. Okay, so by default you can work out the number of electrons. So sodium contains 11 protons and 11 electrons because they are both the same. Now the number that we're going to think about today is the bigger number. Now the number at the top, or the bigger number, so in this case 23, tells me the total number of protons and neutrons in the nucleus. Now remember, those two particles are the ones that have the most mass. Okay, so that is the number that we're going to be using today. So the big number is called the mass number, and it's basically the mass of the nucleus, okay, compared to other elements. They're all really tiny, but it's a comparative mass, and that's the number that we need to use today. Okay, so similar idea of what we've just said. Sodium, you've got a mass number of 23. We only need to worry about the large number today, not the small number. But the small number tells us the number of protons and the number of electrons. Okay. Now the big number is called its relative atomic mass. Now you can't weigh atoms. Okay. So we compare atoms of different elements to the atom of carbon. Okay. So sodium that we've got there, okay, has got a mass of 23 compared to carbon. Okay, and that's what we call its relative mass. Okay, or its mass number. Now it's shown as A and then a small r, so that's its relative atomic mass. Okay, so the A will help you remember that it is the atomic mass. Now we don't need to remember them, but you can use the periodic table to help you. So in this case, we've got carbon as the element, we've got the symbol C, we've got an atomic number of 6, and then we've got a mass number of 12. So the relative atomic mass, the big number, is 12 for carbon. Okay, so this is what we're going to use this morning. Now, what I want you to do is pause the video, and you need to get your periodic table out of your planner, and for these 4 elements you need to look up and find its big number. Okay, so for sodium, I've kind of given you that one already. Oxygen, you need to find what's the relative atomic mass of oxygen, so what's the big number for oxygen. So there's those 4 that you need to look up and quickly write down. Okay, and I'll go through them in a second. Right, so sodium, we've sort of done that one already. So sodium has got a mass number of 23. Oxygen has got a mass number, or a relative atomic mass, of 16. Magnesium is 24, and chlorine is 35.5. Now most of the elements are in whole numbers. Chlorine is one of the exceptions that's a decimal because it looks at different types of chlorine. Okay, so it takes an average mass of the different types of chlorine, which is why it's a decimal. Okay, now we can then go on and look at the formula of compounds and find out what the mass of a compound is. So this is the individual atoms. Okay, this is the individual atomic mass. the work that you did on Friday will help you work out the formula mass for the compounds, okay? So we had this idea of what do these formula mean, okay? Now in this case, again, I want you to just stop the video and see if you can remember from Friday what it was we did. So I'll do the first one with you. So you've got Na, which is a big letter and a small letter. So that is one element. So you're going to look that one up, and that one will be sodium. I've got a capital O, which is for oxygen, and a capital H, which is for hydrogen, okay? Now, because I've got no numbers in this formula, there's going to be one of each, okay? So there's one sodium, one oxygen, and one hydrogen, okay? The next one is ammonia. I've got N on its own this time, which is nitrogen, and I've got H for hydrogen again, but this time I've got a number, okay? Now, that 3 only relates to the hydrogen, so I've got 1 nitrogen and 3 hydrogens, okay? Now this one's a little bit more tricky. I don't think I talked you through these ones on Friday. If you have a bracket, the number outside the bracket tells you that you've got, so in this case you've got 3 lots of whatever's in the bracket, okay? So we'll do it step by step. So Al is one element and there's 2 of those, okay? Now inside the bracket I've got an S, but that whole bracket is multiplied by 3. So that means that I've got 3 S's. Inside the bracket I've got O for oxygen, and there's 4 of them because that 4 only relates to that oxygen. Now because I'm multiplying the whole bracket by 3, that means I've got 4 oxygens inside multiplied by 3 outside. So 4 times 3 would give me 12 oxygens, okay? So I've got 2 aluminiums, 3 sulfurs, because it's outside the bracket multiplied inside, and 12 oxygens. And for the next one, you do exactly the same. So I've got nitrogen, which is my N, multiplied by 2, so 2 nitrogens. I've got hydrogen, 4, multiplied by the 2, so 2 multiplied by 4 gives me 8 hydrogens. I've got 1 S, so that's 1 sulfur, and then I've got 4 oxygens. Okay, so these are a bit more tricky than the ones you did on Friday. Okay, but you'll understand in a minute why we're doing it. Now the last one, you've got aluminium, no numbers, there's 1 aluminium, and then again I'm going to multiply what's inside the brackets. So I'm going to have 1 nitrogen multiplied by my 3 outside the bracket, so 3 nitrogen. I've got 3 oxygens inside the bracket, multiplied by 3, that's going to give me 9 oxygens. So I've got 1 aluminium, 3 nitrogens, and 9 oxygens. Okay, now once you can do that, it means that you can work out the formula mass of each of these compounds, because once you know how many of each element there are, then you simply multiply it by its relative atomic mass, the big number from the periodic table. Okay, so in this case you've got sulfuric acid, and it gives me the formula, which is H2SO4. So I've worked out, now I've looked them up in the periodic table, and I know that hydrogen has got a big number of 1, sulfur has got a big number of 32, and oxygen has got a big number of 16. So what I need to do now is multiply each letter by its right number and then add them together. That's it. Okay, so I've got 1 plus 1 for my 2 hydrogens, 32 for my sulfur, and then I've got 4 lots of 16 for my oxygens. Okay, so 2 lots of 1 for my hydrogens, plus 32 for sulfur, and then plus 4 lots of oxygens for 4 lots of 16s for the oxygen. Okay, so that all comes together as a total relative formula mass for sulfuric acid of 98. Okay, so I'll give you another example, and then you're going to do these yourself. So I've got carbon dioxide. So again, I've got I look at my big numbers, I look at my atomic mass. So carbon has got an atomic mass of 12, oxygen has got an atomic mass of 16. I've got 1 carbon, so I'm going to do 1 lot of 12, and then I've got 2 oxygens, so I'm going to do 2 lots of 16. So I've got 12 plus 2 lots of 16, okay, which when you add them all together will give me a formula mass of carbon dioxide of 44. Okay, so hopefully, I know I've gone through it quite quickly, but hopefully it's quite straightforward. Now what you're going to do is you are going to practice, where's my slide? Just bear with me a little tiny teeny moment. That is... Right, you're going to do these examples, okay? So you're going to write out the formula, write out the atomic masses for each atom, for each element, and then you're going to add them together. So the first one, hydrogen plus, don't forget, it's a big letter and a small letter, so that's the same element. So you've got hydrogen and chlorine, okay? So you're going to work out the relative formula masses for each of those compounds, okay? And the answer's tomorrow.